everyone. In this video I will be telling you the third part of LISP. In the previous second part we have discussed up till here. So moving forward, we have already discussed all this. We have discussed what is LISP, features of it. In my previous, these are we have already discussed definitions, everything. So this we have explained. So we were on this last. So this is the driven method. So this is the main function. You already know the main function, what it does. It calls the function completely in the main function. So int main function, int number 5, we were taking out the factorial of a number. So cout is for writing something on the output screen for getting output. Cin is for getting the input, and output for getting the output you write cout in C++. So factorial of num, then you give, and then the factorial, and this endl is for line end. Fine. Next, cout factorial of a number. This is how you return factorial using iteration. This was the name of the function. So and then return 0. Coming to the fresh topic, that is property list and arrays. So what is property list and arrays? So they say LISP allow you to define single or multi-dimensional arrays using the make array function. An array can store any LISP object as its elements. All array consist of continuous memory locations. The lowest address corresponds to the first element and the highest address to the last element. So this is telling that the lowest element, of course, it contains the first, and the highest is the last. Okay, this will be the number of dimensions of an array is called its rank. So the number of dimensions, that is a rank. In LISP, an array element is specified by a sequence of non-negative integer indicates the length of the sequence must equal the rank of the array. Indexing starts from 0. So it's always in array. You already know, you must have done C. So every in C, in C++, so arrays starting starts from 0, 0, 1, 2, 3. If I write array size is 5, so that means it will be having 0 to 4 values in it. So for example, to create an array with 10 cells named by array, we write set f my array make array and 10. So this is how it look. Arrays number 0, number 1, number 2, 3, and so on. This is the first element, number 0, and the last would be whichever. So the aref is array reference function, allows assessing the contents of the cell. It takes two arguments, the name of the array and the index value. For example, to assess the content of the 10th cell, we write aref my array 9, because it starts from 0, so the 10th element would be 9 only. Okay. So the property list, now that was about array. Now the property list of LISP. Since its inception, LISP has associated with each symbol a kind of tabular data structure called a property list, plist for short. A property list contains 0 or more entries. Each entry associates with a key called the indicator, which is typically a symbol, an arbitrary LISP object called the value, or sometimes the property. There are no duplications among the indicators. A property list may only have one property at a time with a given name. In this way, given a symbol and an indicator, another symbol, and associated value can be retrieved. A property list is very similar in purpose to an associated list. The difference is that a property list is an object with a unique identity. The operations for adding and removing property list entries are destructive operations that alter the property list rather than making a new one. Okay, that's what they are saying. Associated lists, on the other hand, are normally argumented, non-destructible, without side effects, by adding new entries to the font, see icons and pillars. The property list is implemented as a memory cell containing a list with an even number, possibly 0 of element. Usually this memory cell is the property list cell of a symbol, but any memory cell acceptable to setf can be used to getf, and remf are used. Each pair of elements in the list constitutes an entry. The first item in the indicator and the second is the value. Because property list functions are given the symbol and not the list itself, modifications of the property list can be recorded by storing back into the property list cells of the symbol. When a symbol is created, its property list is initially empty. So they are saying when a symbol is created, it's initially the property is empty. Property are created by using get within a setf form. Common Lisp does not use a symbol property list as extensively as earlier Lisp implementation did. Less used data such as compiler, debugger and documentation information is kept on property list in Common Lisp. Now comes the next part, that is mapping function. Now mapping function are a group of functions that could be applied successfully to one or more list of elements. The results of applying these functions is a list are placed in a new list and that new list is returned. For example, the map car function processes successive elements of one or more list. The first argument of the map car function could be a function and the remaining argument of the list to which the function is applied. The argument function is applied to the successive elements that results into a newly constructed list. If the argument lists are not equal in length, then the process of mapping stops upon reaching the end of the shortest list. The resulting list will have the same number of elements as the shortest input list. Now the last topic of this Lisp is Lambda function and internal storage. First I will be explaining the Lambda function and then I would be explaining the internal storage in Lisp. So at times you may need a function in only one place to your program and the function is so trivial that you may give it a name or may not like to store it in the symbol table and would rather write an unnamed or asynchronous function. Lisp allows you to write asynchronous function that can evaluate only when you can encounter in the program. These functions is known as Lambda function. So do you understand what they are saying is they are saying that anonymous functions होते हैं जो बन जाते हैं एक प्रोग्राम में एनकाउंटर करते समय, उन्हें कहते हैं लैम्डा फंक्शंस. यू कैन क्रिएट सच फंक्शन यूजिंग लैम्डा एक्सप्रेशंस के साथ क्रिएट होते हैं. सिंटेक्स ऑफ द लैम्डा एक्सप्रेशन इज एज फॉलोज. लैम्डा पैरामीटर्स इन बॉडी. अ लैम्डा फॉर्म कैन नॉट बी इवैल्यूएटेड एंड इट मस्ट अप्लाई only when Lisp expects to find a function. Example, create a new source code file named main.lisp and type the following code in it. ठीक है, आपको ये करना है write lambda abcx, ये expressions हैं and then this output of this would be when you execute the code the resultant would be 51. तो Lisp प्रोग्रामिंग है, ये आपको इस तरीके से आएगा. इसमें आप अपना बॉड मास यूज़ कर रहे हैं, ब्रैकेट को पहले प्रायोरिटी दे रहे हैं, लाइक ब्रैकेट ओपन, डिवीजन, सब्ट्रैक्शन, मल्टीप्लिकेशन, एडिशन, राइट. बॉड मास की जो फुल फॉर्म होती है आप उस हिसाब से इसे एग्जीक्यूट करोगे एंड देन यू फाइंड द आंसर वुड बी 51. लास्ट टॉपिक ऑफ दिस इज इंटरनल स्टोरेज. तो लिप्स में इंटरनल स्टोरेज क्या होती है? लिप्स इज़ अ फैमिली ऑफ लैंग्वेज, नॉट अ सिंगल लैंग्वेज. फैमिली ऑफ लैंग्वेजेस होती है लिप्स, एक सिंगल लैंग्वेज नहीं होती. Many language is the family. Example, Common Lisp does not specify the internal representation but rather the construct that the structures and functions have to present. In the case of cons, it roughly the equations जैसे car con xy equals to x या cdr con xy equals to y. और ये car क्या होता है, cdr क्या होता है, ये सब एक्सप्लेन करा है मैंने प्रीवियस वाली वीडियोज़ में. And the requirements that cons returns a new object each time it's called. In some Lisp, cons cells are immutable and so the requirements that a new object is returned is not present. Immutable क्या होता है? Which is not visible. Cons cells are immutable. ठीक है? Of course, there are actually implementations and they do actually have the store things and it's not unreasonable to ask how they do that. In general, it's probably best to think of a pawn cell